Hi, this is Math 7, Unit 6, Lesson 5, Reasoning about Equations and Tape Diagrams. This is part 2 of the same thing we were talking about earlier. It says, let's use tape diagrams to help and answer questions about situations where the equation has parentheses. So first of all, we're back to kind of what we had before, solving each equation mentally, and we've done something like this before, except now we have some subtraction ones, right? So we want to get to 5, so we're thinking about what number can I take 1 away from and still end up at 5 there. So in this case, you're probably looking at 6, right? Because 6 minus 1 equals 5, and you're going to work through these ones together. So doing some mental math, you can come up with those numbers there once again. All right, so it's going to be a little variety of things, but we're going to end up here trying to get to 5 there, and here we're going to try to get to 5 still to get to that point. So that would be a 6 minus 1. Here we're still trying to get to 5 because 3 times 5 is 15, so again 6 minus 1. And here we still also want to get to 5, so it's also a 6 minus 1. So this x minus 1 just seems to come all the way through all the equations and be used in different situations to still come up with a value of 5. Let's look at the activity first for number 2. It says draw a tape diagram to represent each situation. For some of the situations you need to decide what to represent with a variable. Alright, so here's our first one. It says each of 5 gift bags, we have 5 gift bags, contains X pencils. Tyler adds 3 more pencils to each bag. Altogether the gift bags contain 20 pencils. So what I know is that I have some gift bags. I know that I have 5 of them, so I could separate this into 5 sections, like so. And I know that initially they each had X pencils in them, and that Tyler adds 3 more to each bag. That's happening to every one of these bags. So they start with X, and we add 3. Starts with X, add 3. Starts with X, add 3. Starts with X, add 3. And in total, there are going to be 20 pencils in each bag. So what does this X variable represent? In our case here, the X represents the amount of pencils that were placed into the bag at first. So first placed in the bag. So that's what the X represents there for us in this situation. Let's look at number 2. Number 2 says, Noah drew an equilateral triangle with side lengths of 5 inches. He wants to increase the length of each side by X inches, so the triangle is still equilateral and has a perimeter of 20 inches. Alright, so we have side lengths of 5 to start with, and it's a triangle. Now a triangle has how many sides? 3 sides. So we know we have a triangle that has a 5 and a 5 and a 5, and what he wants to do is increase them all. We're going to add to the length every time by X amount, so you have one that has a perimeter of 20 inches. So in essence, what we're doing is we're saying I have a triangle. Triangle has 3 parts. Those are my 3 lengths. Each length starts off with 5 inches, but we want to add something equally to each one of those lengths in order for the perimeter to equal 20. That's our goal there. So we have 5 plus X 3 times to combine up to get to 20. For number 3, it says an art class charges each student $3 to attend plus a fee for supplies. Today, $20 was collected for 5 students. So we know if we take our little chart here like such, we know we're going to have a total of $20. That's our total right there. We also know there are 5 students. So we're going to break this apart into sections of 5 because 5 students are there. And for each student to come, they're going to pay $3 to be there plus the fee. What is our fee? We're going to call that X. So in this case, X represents the fee that each student is going to pay to be at the art class, and then all adds up to be 20. And this last one here, it's a little trickier. It says Elena ran 20 miles this week, which was 3 times as far as Claire ran this week. So we know what we know so far is that Elaine is going to run 20 miles this week, which is equal to 3 of Claire. So Claire does hers and it's 3 times as far as Claire. Now what we know is that Claire ran 5 more miles this week than she did last week. So whatever Claire ran last week, we're going to add 3 more to it. So whatever she did last week, we add 3 more to it, last week 3 more to it, and we're going to do that 3 times because that's going to, 3 times, 5 more miles, so sorry, 5 more miles. I was thinking 3 times as far. So she did 5 more miles here, and we have x plus 5 3 different times to come up with 20. In this case, the x represents how far she ran last week. That's what the x is standing for there, is the last week. This x was the fee, and this x was the extra amount of inches on the equilateral triangle. We're going to now use these things to look at section 3. Each situation in the previous activity is represented by one of the equations, x plus 3 times 5, or 3 times x plus 5, and they all equal 20. We want to match those to the different ones. So looking over here at our first one, we had x plus 3, and it was happening 1, 2, 3, 4, 5 times. So that's going to be 5 times x plus 3 equals 20. All right, we're adding the parentheses idea. So 5 times x plus 3 equals 20 is this one. So that's going to be for number 1. Looking at this one, this is 5x, and there are 3 of those. So that's 3 times x plus 5. So that's going to go to number 2. Here you have 3 plus x, or x plus 3, 5 times. So that's going to go with this one. And the x plus 5 3 times goes with that one there. So now we've matched them. We know which ones they go to. Those are our equations. We've turned the tape diagrams into an equation. Now we want to find a solution. So let's look at this first one. X plus 3 times 5 equals 20. And here's our second one. 3 times x plus 5 equals 20. So we'll find a solution here. Work on this first one. First thing I want to do is divide both sides by 5. This will get my parentheses by itself as x plus 3 is going to be equal to 20 divided by 5 is 4. I'll subtract 3 from both sides so that x is left by itself, and 4 minus 3 is 1. So what does that tell us about numbers 1 and 3? What it tells me about the first one is that means that in the gift bags they started with 1 pencil in the gift bag, and then they added 3 more to it. When we look at number 3, it tells you the fee to be in the art class is going to be $1. Now let's look at the other ones that go at 2 and 4. I'm going to first of all divide both sides by 3. So I have x plus 5 equals 20/3. I could write this as a mixed number, and so I think to myself, 3 times 6 is 18. That gets me pretty close to 20. So I know I have 6 numbers in there altogether. And then what do I have left? 20 minus 18 is 2/3. Now I'm going to subtract 5 from both sides so that x is equal to 6 minus 5 is 1 and 2/3. So what does this 1 and 2/3 represent? What it means is that back in the equilateral triangle, I can add 1 and 2/3 inches to each side, so the perimeter in total becomes 20. I also can look and tell that how far did Elena run last week. She ran 1 and 2/3 miles, and this week she ran 5 more, so she ran 6 and 2/3 this week. So that's what she ran last week. So I can tell what each variable represents within each of the stories, and I can represent with a tape diagram or an equation this way. Kind of cool. All right, let's turn the page and see what we have. We have our summary. And basically what we're saying here is that equations with parentheses can represent a variety of situations. And that same equation can represent different things, just depends on what kind of story you want to tell. All right, let's take a moment to look at your homework tonight. All right, so here we go. Here are some prices customers paid for different items at a farmer's market. Find the costs for 1 pound for each item. So what we're given here is we're given a different cost. This is $5, right? $5 for 4 pounds LBS. I can set it up as a proportion if you want to see first of all, and I want to find out how much does it cost for 1 pound is my idea. So if I was to set them up like this, which they're all really set up this way, you end up with just 5 divided by 4. Well, 5 divided by 4, if I did it long way here, we have 5 divided by 4. 5 goes into 4 one time. We bring down a 1. 4 goes into 10 2 times. We have an 8 here. And then we have 4 goes into 20 5 times. So we have 1.25 for A. So A is equal to 1.25. For B, again, it's the same idea, same setup. It's 350 divided by 1/2. 1/2. All right. So what's 350 divided by a half? I could also think about if it's 350 divided by half, I'm also going to double it. I want to do a whole pound of cheese. But if you want to do the math on it, so it's 350 divided by a half. So we can do a 0.5 as the half and put that into 3.5. And we can work that out. Move decimal over 1, move decimal over 1. And we end up with, in this case here, 7. So it becomes $7 there. Which again is the same as doubling 350. For $8.25, same idea. We have $8.25. And we know we have 1.5 pounds of cheese. So we're going to divide that by 1.5 pounds of cheese and coffee beans. Move the decimal over, move the decimal over to figure out what that's going to be. And 15 goes into 82 5 times for 75. We subtract, and we end up with 75 there for another 5 there. Now once I move the decimal over, I need to put up top. So I end up with $5.50 for 1 pound of coffee beans. For D, we have 6.75, and that's divided by 3/4, which can be written as 0.75. Move the decimal over 2 spots, put it right up top right away. 75 goes into 60 times, goes into 67 0 times. It goes into 675. We're going to go with 9 times. 9 times 5 is 45. 9 times 7 is 63, plus 4 is 67. So we end up with $9 for 1 pound of fudge. And finally, we have $5.50 for a 6 1/4 pound pumpkin, so it's 6.25. And again, we're going to move that over 2 spaces, and we can already tell that I'm going to have some extra zeros there. And we're going to work this out. What we're going to end up with is it's going to cost us 88 cents for 1 pound of pumpkin. And you can figure that one out too. All right, so some long division there. Are there some shortcuts and shorter ways? Yep, there certainly are. You could do some quick multiply by the reciprocal type of thing and get some solutions there. I wanted to do the long way for you so you can practice some long division. All right, number 2, find the products. All right, so first of all, I have positive and negative, so I'm going to have a negative answer. Negative and positive, I have a negative answer. Negative, positive, negative answer. Positive, negative, negative answer. So let's see if I can do any reducing first of all. Any reducing the diagonal? Nope. Up and down vertical? Nope. So I'm going to have negative 8, which we already have, over 15 for the first one. Here I can reduce a 5 and a 5 and a 7 and a 7. So I basically have 1. Here 39 reduces 39, so I'm left with just the 2. And here 1 and 2 reduce there. 1 times 3 is 3, and 5 times 2 is 10. So I have negative 8/15, negative 1, negative 2, and negative 3/10 for my solutions. All right, number 3. 2 stories. Family buys 6 tickets to a show. They also each spend $3 on a snack. They spend $24 on the show. So what do we know? Each family buys tickets, right? So we know our family is here, and there are 6 of them. 1, 2, 3, 4, 5, 6 of them, right? They each spend, so they each buy a ticket, and then they spend $3 on a snack. So this is going to happen 6 times. X plus 3, X plus 3, X plus 3, X plus 3. and then they total spend $24. When we look down over here, I see I have an x plus 3, and that's happening 6 times, meaning this same pattern is happening 6 times in a row. So this is going to match the family story there, right? Over here, it says Diego has 24 ounces of juice, and he pours equal amounts for 3 of his friends, and then adds 6 more each. So Diego's going to have 24 ounces to work with, and he's going to break that up into 3 sections for his friends. He's going to pour them something and then add 6 more ounces for each. So he pours them a certain amount and then gives them 6 more each. So that's what he poured, and that's what he gave them additional. So there's our x plus 6, and it happens 3 times. So this is going to be our juice story there. Those are our 2 equations and which stories that they go with, which is going to be part A. So part A is which story do they go with. Now we want to look at what does x represent in each equation. In our equation here, x represents the tickets in the first one, the cost of a ticket. And over here, that's going to be the amount he pours at the beginning. Is our first x there. So that's whatever that ounce, the amount of ounces is going to be, is our x value. And our ticket cost is the x value there. Find the solution to each equation and explain and show your reasoning. So let's look at each equation and figure that out. So here is our juice equation. We have 3 times x plus 6 equals 24. I'm going to divide both sides by 3. So that x plus 6 equals 8. 24 divided by 3 is 8. Subtract 6, and x equals 2. So for the juice story, what it tells me is that he poured everybody 2 ounces of juice to start with, 2, 2, and 2, and then added 6 more ounces to each one. That's what the x tells me. And for the family, we have 6 times x plus 3 equals 24. We divide both sides by 6, so x plus 3 equals 4. We subtract 3, so x equals 1. What does this tell me here? This tells me that a ticket to the show costs $1. And that's what a ticket for the show cost was $1 there. So that's answering parts A, B, C, and D of number 3. Let's take a look at number 4. All right, for number 4. Here's a diagram and its corresponding equation. We have x plus 1, and we have 1, 2, 3, 4, 5, 6 of them. All right, so find the solution and explain your reasoning. So how does this work? We know we have x plus 1 happening 6 times. So what we can do is we divide both sides by 6 in order to find out what x plus 1 is going to be equal to. 24 divided by 6 is 8. So that tells me that each one of these little sections has a value of 8. And if you think about it, right, what is 8 times 1, 2, 3, 4, 5, 6? Well, 8 times 6 is going to be, 24 divided by 6. Why do I keep thinking 8? Oh my goodness. Sorry, 24 divided by 6 is 4. Oh my goodness. So sorry. So we have 4. We have 4 times 1, 2, 3, 4, 5, 6. So 4 times 6 gets you 24 is what it should be there. Now in terms of the x value, so sorry, we're going to subtract both sides by 1, so that x is going to be equal to 4 minus 1, which is 3. So we have 3 is our x value. We add 1 more to it to make 4, and when we do that 6 times, our sum total is 24. Okay, number 5. Below is a set of data temperatures. The range, might be a new word for you here, is a set of data is the distance between the lowest and highest. So lowest and highest value, the distance between those. So what's the range of these temperatures? Well, what's our highest temperature? We have 9, -3, 22, -5, 11, 15. Our greatest temperature is 22, and our lowest temperature is right here at -5. So when we find the distance between them, we'll find the difference. So we'll do 22 minus a -5, and we'll take the absolute value of that. So this becomes 22 plus 5, and that is just going to be 27. So the distance between the highest and lowest value is 27 degrees Celsius. And finally, number 6, the review here of percentages. It says a store is having 25% off sale on all shirts. Show 2 different ways to calculate the sale price. I'm going to find the sale price for a shirt that normally costs $24. Alright, so a couple ways here. The first way we tended to do it when we went over this lesson is we would say, well, let's do 100%, right? 100% of the cost, and we would subtract from that 25% of the cost of the shirt. So 100% as a decimal is written as 1, of becomes times, and cost, in this case here, was $24 to start with. That was one thing, and then we subtracted that from 25%, which as a decimal became 0.25 of the cost for the other part. And then we used our multiplication properties and said, well, let us take a let's combine this and take the 24 out. So what I did is we would go 1 minus 0.25, and we multiply that by the 24. So 24 is in both of those there. 1 minus 0.25 was 0.75 times 24, and 0.75 times 24 equaled 18. So our cost was $18. That was one way that we did it when we did this same story earlier, or same type of problems earlier. Another way is to say, well, 25%, so 0.25% of the initial price, $24. So 25% of the original price, $24, is going to be $6. And then we take that discount price, that's going to be our discount, our savings. Then we take that and we do the original minus the discount to find out our sales price, which is 18. Both methods work, just depends on which way you want to do. This one's a little longer because I explained it a little more, but basically you're going to either multiply that and then subtract, or you're going to subtract and then multiply. Just depends on the order you're working on there. That's it for today. Have a great one. We'll see you next time.